Okay, am I streaming? I don't know. Am I streaming? Am I live? Not live yet. Yes, I'm live. Awesome. This is my first stream. I was learning how to configure OBS. Um, this is my first stream. I was learning how to configure OBS. Um, this is my first stream. I was learning how to configure OBS. Oh, nice. Nice. I still don't
This
know.
is my first stream. I was learning.
I still don't know how to put this chat in a different activity level, in a different room, but I'm learning, guys. Okay, guys, so here we go. This is my first streaming, and I'm not sure um, what to do here, but let's do it anyways. um, let's do it anyways. Let's do it anyways. What we are going to talk today is okay. It's about serverless computing. Let's do something here interesting because I've been working with serverless computing for a while, and I think it's a good idea to give you some insights of my learning experience of serverless. And I thought that was a good idea. Oh, this is nice. Seasonal holidays. The doodle. This is nice. Okay. Um, Happy Christmas, everyone. This is the Thurnberg. This is my first streaming that I'm doing on Twitter, on YouTube. I'm planning to also go to Twitch. I'm not sure if it's a good idea, but in any case, I want to share all the knowledge that I've been gathering for my latest years of software engineering, and I want to share it with you because the main reason I do this, I just want to make clear this, guys. The main reason I do this is because I think it's a great way to learn, and I'm all in on learning. I'm always be a fast learner and a very good learner, and I like to learn a lot of things. The problem that I have is very hard for me to synthesize what I get when I get good at it. And I think when you do these type of things, you don't need to really get good at something, only that sharing your ideas only sharing your ideas in the best way possible so people can gather and get some feedback and get some valid insight and get some value. I'm not sure if this is a good way to start the streaming, but I want to make clear I have a lot of knowledge on different areas of software engineer, mostly because I've been over it about 15 years now. My dad is a software engineer too. He teach me to code since I was a kid. The thing is, when you go over and over different companies, you don't specialize in a specific industry. And I think that's a big mistake that most people made, most software engineer, including myself. When you have an expertise area on a specific industry, it's easy for you to grow. And if you saw my other video that I just shared, I think the video is related with, let's see if I can find you that video. The video is related with um, one of the best advices that I just I think it's not scheduled yet. I have scheduled. Let me see. Well, basically the video is talking about one of the best advices that I can give to a senior or a junior software engineer. It's just talking to myself, to my early self, on how you can approach your career path in a different way that I did, and don't make those mistakes that I made. But in general, I want to talk to you today about serverless computing. I don't want to talk to you about other things about that. And for that, I think we are going to start finding the Eric. Okay, Eric Johnson. So if you don't know who Erin Johnson is, let's see if you can see some details here who about he is. So as a principal developer advocate, so he's a principal developer advocate in AWS. Basically, it's everything you need to know from him. But I think he's very good. He's a very funny guy, and he has very good information about serverless. So I want to speak a little bit on one of the videos that he has on serverless computing. But I'm also going to find, because we're going to talk about serverless computing in Azure is where I have the most experience. But I want to find with you first the fundamental videos that I want to share with you. I'm going to discuss with you on serverless computing. Let me see if I can find those links already. Okay, it is logic apps, Azure functions, Azure functions. Okay, here we go. Azure functions. Let me see if I have at the end the links that I want to share with you. What? Okay. I thought where I have those. I can't find it. I'm not sure why. So the reason is because I was using a different note taking. I was using OneNote, a Notion, and I even use Visual Studio Code for with the plugin, with the Obsidian plugin. And so I have tested many note taking approaches, and I stick to the simplest one, which is OneNote. I just create one page for the notes that I want to add it when for a specific topic, and I put everything there. Every time that I just going to find something or going to relearn or review something, I just go there, and that's all. I create different notebooks for every area of interest in my life. That's how I go, guys. I think this is very important, the note-taking approach you follow. There is a lot of Obsidian plugins, Notion. For me, I choose simplicity over anything else. This is on serverless event-driven trading platform that I just going to create a video later. But where is that specific? I think there you go. There is a really good serverless videos that I want to share with you.
Thank you for coming to this session today.
But I want to share the basics one, because if you are starting using serverless in your life, in your career as a software engineer, I believe you should start with this specific video. Oh man, I had to get good at indexing these ideas, because now I just navigating the journey of serverless. Okay, let's just find Eric Johnson serverless. Okay. This is not. Okay, building distributed application event-driven architecture. This is the video. Okay, we are going to discuss this video.
Has to know about is the bug.
And we are going to find another video which is related with actual function, which is one of the services you can approach. You can approach and develop serverless application. But for that, I need to find the guy that shared that video. This thing is crazy. AWS serverless. not in jobs. I don't wanna, not in jobs. What is this guy? It's been a while since I found this guy. Let me see if I can look on it. Okay, I can't believe I lost that specific video. Okay, let me see if I found it on Twitter. Because I have the guy, I follow the guy, Serverless. No. Man, I can't find this. I can't believe I lost this video. Let me look again here, guys. Azure function. How do I know Azure functions? As you know, guys, I just totally very bad at streaming. But how do you get good at something? Just doing it, right? Someone is twitching. Send me some code for something. I'm not sure if that one. Okay, sorry guys. Is some delivery guy on the front of the door. Okay, what we were talking about. So I'm trying to find one specific video on Azure functions, which I think is one of the best video you will not find easy. But I haven't found this video, and I think it's very important for us in this streaming, since we are going to talk about serverless, to talk about this specific video using Azure functions. I have a lot of knowledge on Azure functions, but I can't believe I don't have. Yeah, I saved the screenshots, but not the link, which normally OneNote allows you to save the link. Okay. There is this guy that he specializes in serverless. Let me see if we can find it here. Following. Yeah, I found it. Yang Kui. Okay, Yang Kui. He's specializing in serverless, and he did an interview. Let me see if we can find it on his YouTube channel.
In this lesson, let's talk about
Okay. Videos, content mapping, domain driven. Azure functions. What is the video? Azure. We found it, guys. We found it. How was possible that I
Welcome
lost
back
this
to
video?
another episode of
How is possible that I lost this video? Azure Functions. Okay. Azure Functions deep dive with Ian Griffin. So I think this is one of the best video anyone should start looking when they're going to use Azure Functions to develop event-driven solution, okay, in Azure. But first, I want to also share what is, I believe, the first video every developer should see for understanding event-driven architecture. Okay, so
these things happen, right?
so let's go move forward a little bit. So he's just
Turns out
Eddie Johnson just took his way
I'm a phenomenal drummer.
He is a principal developer advocate in AWS, solution architect for 10 years, developer for almost 30 years, father of 5, husband to a superstar. Okay, that's awesome. Agenda. He's going to review some enterprise integration patterns and event-driven architecture, and how cool is he maintaining idempotence on this specific, which is very distributed type of distributed system, which is very hard to do if you don't acknowledge the same edge cases that you need to acknowledge. Okay.
Distributed apps, the struggle is real. So we're going to talk about how AWS and coupling is a measure of independent.
Okay, coupling. He just mentioned an important work on architecture. So coupling integration magic work. Coupling is a measure of independent variability between connected systems. The coupling has a cost both of design and runtime. Coupling is not binary. Coupling is not one-dimensional. Coupling is basically it help you to segregate your components in a different way. Okay. The many facets of coupling, technology dependency in Java versus C++, location dependency, data format dependency, data type dependency, semantic dependency, temporal dependency. I think this is not necessary for we are going to. I want to go directly to the serverless ideas, right? So I don't want to spend some time just reviewing things that we don't need to discuss in this video.
Right, and so this is important.
But this is a very important point. The appropriate level of coupling depends on the level of control you have over the endpoint.
So we think about what are the reliances and how do they look.
Why do you think this is important? How do we know if someone is writing here? View, docval, statusval, stats. Multi-view window, always on top. I'm not sure how to see my chat here. Man, I have to get good at this because I really enjoy it. I like it a lot. Do I need to open YouTube and put it here maybe? Let me see. I just want to see how I can see the chat. Okay. Okay. It seems that there is no way to pop up. Yeah, we can pop up the chat. Oh, now. Yes, we can do that. So we can just close this then. Yeah, I just want to see if someone... Okay.
Right, and so this is important. So we think about what are the reliances and how do they look. Right? So
why this is important? The level of coping depends on the level of control you have over the endpoint.
I can be a...
And that makes a lot of sense. If you have one component that depends on another, but you have no control of the other dependency, maybe it's better to just have a different design that when you control two components and you can make changes and that can affect the other, also can control the dependencies level of between these two. Okay.
Okay, my app isn't going to fall on its face if their app falls on its face. And we see this a lot. In the wild, we see we're using a mapping service from somewhere. We're using a payment service from somewhere else. And if they shut down, we shut down. And when we shut down, we stop making money, right? And so this is important. So we think about what are the reliances and how they look. So I want to get into soon, and then we're going to get into some actual patterns, right? These are some patterns that we see, and some of these maybe you'd be like, Eric, I understand this, and some of you are like, oh, I hadn't thought about this.
I had an interview few weeks back where I was explaining one of the best way to improve APIs using serverless computing, and the guy made a question at the end, right? Why you didn't mention asynchronity when you want to improve your APIs? And I said, well, if you are talking about serverless computing, asynchronous or synchronity, depending on the component that I already highlighted with service broker and some dependencies. So I highlighted a group of level of services that asynchronity was embedded on those things that I just already mentioned, and that's what I think. Eric start here talking about synchronous request response model, because you need to understand the difference between synchronous request and asynchronous request model. With serverless computing, you can achieve both, and you can achieve it really good, really nicely with not much effort, but you need to understand the differences.
So kind of all levels, but let's jump in. So the first thing we have is a synchronous request response model. And if you
this is straightforward, guys. You must know about it. Synchronous request response model. You have a client, you have a server, you have a request, and you have a response. Okay. The advantages: you have low latency, simple, and fast forward. So basically, you can have a response no matter the level of success of the request you made to the server. Okay. So that response can be a fail, can be an okay, can be any group of response level that you can achieve, but you can have it really fast. You can have it as soon as you add the request enter to income to the server. Okay, let's go to the other one. I think we don't need to discuss this one. Okay, but what happened?
You get this idea of failing fast. There's disadvantages.
Oh yeah, this is the disadvantage with he mentioned on why you should start using another architecture pattern.
Okay, we already kind of talked about it. My receiver fails, my sender's done. Okay, we're not doing anything until we fix the receiver, right? So you have these disadvantages. The other thing is you have receiver throttled, right? So you get this idea of, okay, yeah, we built this system, and it's great, and it's chugging along when we get, 3 requests per second. How many? Okay, good. There's always someone new who wasn't here for the rules. Like, that's a 1. But it gets weird for... So as you start building up and you're no longer 3 per second and you're 300 or 3,000 per second, your single senders go, whoa, I can't handle this. I'm shutting down. So it becomes a major problem when you get this receiver throttle. So it becomes a major...
Okay, basically what he's trying to highlight here is that when you have a single point of receiver, you have a single point of failure, which makes your system architecture more prone to fail. Okay? And you have to throttle somehow on those specific requests, because you need to have certain type of control on the amount of requests you're going to accept by any specific receiver. In this case, any server. Okay, there are many services that can help you throttling. Even the API management can help you configure this. Akamai, you can help you do this, and there is a lot of API gateways that also help you to do this. But any case, I think the way he started this video is very good, because he gives you the sense of the difference between some model of communication between client and server, and after that he gives you a more deep analysis on the serverless advantages.
Problem, you get this receiver throttle. So we look at it, another way we look at this is what we call an asynchronous or point-to-point model, and this changes that pattern. Now, it's not going to apply to 100%, but I promise you, and this I'm going to pick a random number out of the air, but most processes, there's a word, sometimes they pay me to speak at Amazon and I just forget words, but most processes that we're running synchronously, or a lot of them, can be converted to asynchronous. One of the things we get a question all the time is, how come your Lambda functions only run for 15 minutes, right? And they go, we have a process that's running longer than 15 minutes and it just can't be changed. It's impossible to change it. I push back on that usually. And there are some processes in the world that are that way. But a lot of times you push back and go, really? Really, really, really? Have we thought about this? Have we thought about starting the process and then waiting? And that's what this looks like, as an asynchronous or queuing, right? So now we have our sender receiver, but we've put this queue in the middle of it. Right? Queue can look like a lot of different things. Rather than queue, it can look
Okay, here enters one of the word he already discussed in the beginning, coupling. Okay, when you start adding this type of services in the middle, there is a lot of services that can give you a queue in Azure. So we are talking about Azure. Okay, we're not talking about AWS. With AWS, you might use CNQ, CNS. I think AWS Q services. I think it's MSQ is in Amazon, but in Azure you have different type of queue. In Azure you have Azure Service Bus. With Azure Service Bus, I'm going to make a video only on Azure Service Bus actually, because I work a lot with this enterprise message broker. You have an Azure Service Bus that give you the possibility to create different queues, also topics. Okay, you have topics and queues. There is a difference between them, but it's very important that you also know that with Azure Storage Service, you also can get queues. Okay. Okay. You also, so that there are different ways you can have this queue that he just mentioned about. And just mentioned a couple of them in Azure. Okay. And when I like a lot this type of the coupling your application. Okay. When you use a queue, but not always you can use it. Or I see a lot of serverless computing using queues where they don't need to use it. Okay. You can have a sender that push the data directly to Cosmos DB. To any other data layer, if you want to process that data later. Okay, you don't need a queue. You only need a queue, in my opinion, when you need to decouple two components. Okay, when you want to hold these applications for a period of time, even though you don't need to consume those events or messages, which are very different. The event and messages are different. We're going to talk about the difference between them in a different video. Okay. I'm just doing this stream on my first stream with no preparation at all. This is everything from my mind, from my experience. I promise the next videos I'm going to prepare even better, but I just want you to understand the difference between and the advantage of this specific component. Okay, let's
SQS, obviously, different things you can do. But the idea here is now I no longer have a sender talking directly to a receiver. So my advantage is it decreases temporal coupling. Now I said that with a lot of emphasis because I don't know what that means. But no, temporal coupling says, look, this idea of now I'm down, the receiver goes down, sender can't send anymore. It decreases that. It decreases or resilient to receive failure, right? So if the failure goes down, so let's explain that for a minute. If the receiver goes down, then my sender doesn't care.
Okay, yeah, I'm gonna skip this part. Basically, when you put a queue in the middle or any type of service broker a specific decoupled component, a topic or a queue, you can decouple these two components and you have some advantages. You can also have disadvantages. Okay, so the advantage is you decouple these two components. You can acknowledge for failures in a different way. and you can decrease or increase your consumption rate of the receiver with any configuration manually or automatically configuration that you want. So you can consume these specific events in a different way and acknowledge the receiver in a different way. You can also add some different patterns, like low leveling patterns. Let's say that you have a million requests per second, for example, which is very hard to achieve. But a million requests per second, let's suppose that you have a queue in the middle receiving those events. And you can basically have different receivers, different consumers just consuming this pattern in a different way and inserting it into the database. If you are going to send this million requests directly to a database, you will have a lot of problems, right? So that's why you insert this type of components in order to manage the prompt failures that you can control if you don't have this type of services. Okay. Also adds more delay and more latency to the services, because there is more services in the middle that need to proceed these messages. But often, architecture design is about context, and context give you the reasons why you should say something. Context give you a specific architecture context for a specific company, in a specific team, in a specific structure business model. I give you the reasoning to take different approaches on the decision making process of your architecture design. Okay, so that's why it's important for you to understand that every time you see an architect diagram, you need to understand there is a lot of hiding information that you don't have. So you have to make assumptions on why the team did the analysis and the design in the way they did it.
My sender's just going to keep checking stuff, and they're putting features for a moment. One, customers, when they click send,
okay, this is a very important advantage that the service broker feature has. So you can create a queue, and the queue naturally has the letter Q that you can configure in some ways. So one of the main configurations you can do is, for example, you can have different paths of the letter Q, okay, and you can send automatically events depending on a specific characteristics. But you also can configure a time to live for a specific queue, okay. So its TTL expire exception can be raised. You can have a maximum delivery count. You can have error while processing subscription rules. So you can configure different events. So different patterns on how the events will go to a different queue. Basically, a delta queue is just a different queue, okay, with event or messages that has some issue, depending on the configuration you provision to the service broker. Okay, and this is very, very important to understand, because this is a separate queue where you can process and retry other events. Okay, you don't need to retry events that's why sometimes retries on the main queue is not necessary. Okay, because there are always ways to acknowledge that the event didn't came to your. Of course, this also depends on context, but if you have the deleted queue, you can apply retries in different ways, and you can always find a way to reach them out here on the other queue.
All right, here's the deal. We're reliable, but we lost your credit card number. Go ahead and give us a second time. We think we've got it. Okay, we're gonna give it another shot and see how that works out. Right? We're considering sometimes that data. And I like work at SQS is when you actually block a queue, then the other one can process it. So that's how we deal with that. All right, and I'm going to pick it up just a little bit because we lost some time in the beginning. So I'm only going to say every third word. So here we go. Ready? All right.
Okay, so just to summarize here, as I said before, so you have a sender that sends a million of requests, and you have a queue in the middle that can process and hold those requests for a certain period of time. If those requests are not consumed, you can send those requests or events to a deleted queue, which you can deal with them later in the way you want. You have different receivers that can consume this queue. You are decoupling these two components. Okay, the advantage is that the main advantage is you have main services holding all your data. Okay, that is important to be consumed. The disadvantage that I see here is that you have a single point of failure if you don't have different queues, if you don't segregate responsibility between the topics that you create, if you don't split the data to different, if you don't have geolocation, for example, which is very common to some companies don't have geolocation configured on their own architecture. So you have different services in different data centers. In order to one data center fails, you have the messages going from one server to another or replicated to three data centers, for example, so you don't lose the data. Okay, and this advantage backlog recovery time, I don't know what he means with that specifically. Fairness in multi-tenant system, I don't know either what that means.
So in this idea here, when we're setting things through, now there are a couple of disadvantages. I'll talk about AWS. The principle stands if you're in Google, you can use SubHub there. If you're in Azure, you can use the data.
Okay, this is the main, he's talking about Amazon SQS, the service that I just highlighted before, which is just a queue services from Amazon, a cloud provider, which holds these characteristics: fully managed message queue, scale almost infinitely, simple, easy to use API with the letter queue support and standard first in, first out options, which I think is in most queue services. These are the characteristics that holds a service broker or a queue service, to be more specific. Okay, because in service broker you can also have topic, which you can have different patterns of messaging in and out. But in general, what I'm trying to say here is that mostly of queues services that you have right now, any cloud provider holds the same characteristics. Okay, so he's, of course, he works in AWS, he works in Amazon, so he will put in context this presentation with Amazon product. So my whole idea is you understand these principles and you can use them in any cloud provider you choose. Okay, there are different configuration patterns, there are different configurations that you may hold, but it's very important for you to understand that this type of presentation holds information so you can apply this type of serverless computing knowledge in any cloud provider. The only thing you need to understand how to configure this specific service for any specific cloud provider, which is a different deal. Okay. Okay, we have another pattern here.
All right, so with this, if you think about this idea, we do this a lot. How many of y'all are developers? Okay, so good, the entire room, or most of the room. Okay, I know you, all right? Developers, how many have sat down and said, I'm going to make the next amazing authentication system? We do everything. You're shaking good. I'm glad to see it. Shaking your head no. But the reality is, as developers, we like to do everything in code because our code is better, right? Okay, we're together here. Eric Johnson's code isn't better than anybody's. But
okay, this is a very important take that I think is highly imperative to mention. Not because you are a good developer, it gives you you should take everything for granted and make the wheel again. Okay, if you are a great developer, you should understand how to leverage your tools and your services better. And I think that the main reason he just mentioned this is because in Azure and AWS and GCP, you have a lot of services that can save you a lot of time. Of course, there is the disadvantage about that is that you will have to pay for it. Okay, but even though you will have to pay either way, because if you have to develop, your time always has some value. Okay,
developers tend to do that. I can do the magic. Right? So do that based on my advantages. First of all, you get increased location coupled like this, then IoT devices, things like that. Actually, to this. So then it's like,
okay, the asynchronous point-to-point border road. I think you can achieve this with topics, for example. It's basically just similar to a queue, but a topic you can segregate your data automatically in the same service broker using different filtering patterns. Okay, and you can have different receiver consuming these specific events, and I think this logic is this pattern is very important because it's not the same for you to have different queues and have a topic with different filtering if the data is correlated somehow.
You have hundreds.
Also, you have different advantages. You have to read about them, the difference between the services you use. You have to read the advantages and disadvantages of using, for example, 4 queues and using just maybe purple and blue are data that is correlated somehow. The data set that similar, you can filter them, and maybe green and yellow is also related to a specific data set that you can use just 2 topics instead of 4 queues. There is advantage of this and also disadvantages between using each of them. For example, the data size. The data size is very important. Okay, the data structure is easy to filter and configure the filters. The receivers, for example, if you have control on the receivers, maybe you have control. If you have restrictions also on cost, so you can configure a queue or maybe a topic. The throughput characteristics that you want these receivers consuming these events or messages is also a valid thing to think about when you're choosing your service. For example, instead of using, in this case, Service Bus, you can use Event Hub, for example, which is more for reliable systems.
And hundreds of lines of right? I'm not still bust. And he doesn't need any logic around it. He doesn't need to know where anything's going to go. He just kicks events into the bus. Here they are, right? And the event bus has the logic. Oh, that's really bad color. This says reduce.
Okay, I'm not an expert on AWS integration services. I believe that Service Bus, we can find it here. I believe that Service Bus is a different, they handle different sets. So in Azure, a Service Bus holds queues and topics. You can configure these 2 different. In AWS, they have SQS, okay, which basically is just a queue services. But they also have AWS Bus. I haven't used Bus that much, but I believe they also have Event Bridge. Yeah, I believe this is more related to the service boot topics. So you can filter. It's just basically a queue with the filtering capabilities on the top. Let's see. Enterprise Service Bus is a software architected to pattern that support real-time data exchange between this disparate application. Large organizations have multiple applications that perform various functions. Okay, we already talked about this protocol and security restriction. The enterprise service will make application integration easy by performing operations like data transformation, protocol conversion, message routing, application path relevant data to SB, and it's convert and forward the data to other applications that need it. Okay, the benefits: improve application integration, developer efficiency, visibility and control, which is true because you have you can develop patterns and login automatically when you work with these services. How does enterprise service bus work? I don't wanna. You have an endpoint, you have an adapter component, and you have the bus. The bus is the core enterprise service bus component for messaging exchange between endpoints. It uses a set of rules or policies based on various criteria like message type, content, or destination to route messages. You can define the policies in the SB configuration to meet the requirement of complex business processes. It uses a variety of communication protocols such as HTTP, GMS, and FTP communication with the endpoint. Yeah, I don't want to stop here that much, but they also have event bridge to build event buses that connect application data from application, and we need to understand the difference between them, which I don't know yet. So, but basically, my belief is that it's just similar to Azure Service Bus, which holds the queues and topics, and you can filter the data and the events that are going from the same platform, from the same services. And I also, another difference is the protocols they use. Okay, the protocols they use on the protocol they support, actually, which also makes a difference on the interaction type you want to build.
This is location coupling, if you can see it. I need to change color of that. That's wrong. So again, it doesn't need to know anything. And it's efficient for senders and receivers. We don't need to have the logic in there. All right. So we use a service called Amazon Event Bridge. On Azure, it would be Event Grid. GPC would be Pub Sub. But the idea, again, is we're dumping information into this bridge, and the logic for routing becomes part of the bus, right, instead of the client. So I can change the logic without changing the client, right? So let's just quick thing over how AWS or Amazon Event Bridge works. First of all, you have these multiple targets. And it can be anything. It can be AWS service, your custom apps, SaaS apps. We have, Mongo directly connects to this. Microservices, all kinds of things. And then you can have different buses. You have your default. If you have an AWS account, you already have an Event Bridge bus because you have a default. You have custom event buses and partner event buses, all kinds of things. You can archive, replay. There's all kinds of technology built in. But then you have this. Okay, and these are the rules. This is where Event Bridge gets.
Okay, Event Bridge is just similar to Event Grid, which is just basically hold different protocols and also send the data with different throughput to the clients. So, but it also accepts rules and filtering. Okay, I just mentioned about this. Oh, he's just going to explain the different beta routing rules you can apply. You can apply content-based routing rules, which is just basically filtering depending on the data, some data format you want to. Okay. Okay. Now that we review different components. Okay, different architectures patterns, synchronous and asynchronous, and I think he's just starting all the half of the presentation so you can understand why using this type of services will make you more effective when building this type of architecture designs.
With Amazon Event Bridge? All right, so those are some of the patterns we see. We talk about asynchronous, we talk about getting out of synchronous and moving into asynchronous. We talk about buses, routers, different things like that. So the next thing I want to do is I want to talk about Event Bridge or event-driven architecture. All right, so first of all, we talk about an event. When we talk about event, I'm going to get real technical here. I haven't been terribly technical. I've been talking about some services and some patterns, things like that. When we define event-driven architecture, this is what it is. All right, and I want to see lots of people taking notes, okay? Because this is what it is. Something happens, and we react.
Can you see that? Something happened and we react. I believe this is not like the best. It's not bad though, but I believe it's not the best definition. So let's see what we can find. Event-driven architecture definition. Okay. An event-driven architecture uses events to trigger and communicate between the component services and is common in modern applications built with microservices. An event is a change in a state or an update, like an item being placed in a shopping cart or an e-commerce website. Event can either carry the state, the item purchase price and delivery address, or events can be identified and a notification that can order what shipped. Event-driven architecture has three key components: event producer, event routers, and event consumers. A producer publishes an event to the router, which filters and pushes the event to the consumer. Producer services and consumer services are the couple, which allow them to be scheduled, dated, and deployed independently. Okay, let's review another. Let's see what Wikipedia has. Event-driven architecture is a software architecture paradigm concerning the production and detection of events. Event-driven architecture are evolutionary in nature and provide a high degree of fault tolerance, performance, and scalability. However, they are complex and inherently challenging to test. EDAs are good for complex and dynamic workloads. Okay, this one is a little bit better. It's just basically an architecture software paradigm that handles events or messages, because not all the routing components can only hold events, and there is a difference between events and messages actually. Okay, there are difference in the intent, and there are also difference in the data structure. Okay, I think Eric just mentioned this next before.
Can we do it again?
In any case, I think it's a very good simplified term. Okay,
I can do it again. Event-driven architecture. Something happens,
and you react.
And we react. So the thing is, you need to have an event. What is an event? Yeah, it's anything you want it to be a lot of times. Something's happened. First time I ever talked about event-driven architecture, I was actually doing an IoT demonstration. I had one of our AWS IoT buttons. It says,
I am disconnected. Okay, the streaming was disconnected, so let's continue.
It said, stop loving me right now. I'm tired of your love. My wife, she tells it as it is. So something happens and we react, right? So this is an event. Pretty straightforward. The main thing we're looking at is we have some metadata, idempotent key, which we'll get to, and your order ID. Okay? So we think about how we do events. You can have a sparse event versus, you can have a little more data, right? Sparse events versus full state description, right? And so the idea here is with a sparse event, you can run into problems where you say, hey, I don't have enough information here. Okay, I need more. So how do you handle that? You can have a pointer to more data if you need to. But the idea is when you're planning, and I heavily encourage you to plan events. And there's a guy named David Boyne who does a lot about this. You've ever heard of Boyne123 on Twitter? He's part of our team. He does a lot about planning your events, and this is one of the things you think about. How big do I make my event? Well, I can do it when there's not quite enough, or I can add a little more information. Event schemas should be backwards compatible, right? So one of the things to understand is as I start adding more information, I need to be able to support that. Okay, so I can actually get bigger, but there's a cost to calculate values that can increase over time the more data you add in. So one of the interesting things is with data here,
guys, listen this part. I'm gonna fill out my water bottle. Fill out this part because I think he's here when he mentioned the importance between event and just a message. Okay, I will come back.
Actually, I want to finish that real quick. With data, if I do order ID and one of my systems expects it to be camel case instead of dash, so I change it to camel case, well, now I've broken a lot of things. Okay, so now I'm maintaining order ID as camel case and as snake case. So things to think about is you add, if all the data is in the event, you have to support all the data in the event as you're growing. So as you're planning your events, think about how much is too much, right? And where can I store it? Where can they get more? All right, so one of the things we heavily encourage is that you choreograph events between domains using subscriptions. So this is that dispersed, right? This is the dispersed systems. We're talking about building systems that are all over the place and have different people. A lot of times, hundreds of people are building this application. They build this one little section. How do we talk? Well, a lot of times we set up APIs. You call this API, you can get this. But a better way of doing that is events, and this is where the event-driven comes in. Because between these two domains, I have fulfillment and I have retail. I can say, hey, instead of you having to call me all the time and you calling 30 people, just notify me when something happens. So retail says, all right, I'll let you know when an order is created. So they use something like SNS or an event bridge, one of the things to communicate between the domains, and they just throw the event out there. And that's much easier than saying, all right, what 30 services need to know when something was created? I have to call an API in every one of them. I'm going to miss one, I promise you. Right? So instead, I'm going to send one event out, and all of you just throw a rule onto the event bridge bus when you want to know. You see how that kind of frees up the system? Okay. So what happens is we create this order, and then we use orchestration inside of here to handle things. Remember I said, hey, we need to do some things in order. We'll talk about that in a minute. So we'll do orchestration where we have an inventory manager, an invoice manager, they create an order, and they kick it out. So we notify them using choreography, but inside the domains, we use orchestration. And for that, we use a tool called step functions, right? And different services have this. Azure, I think theirs is.
Okay, you can also implement your receiver without the need to orchestrate, or what they mention, orchestrate the event. Okay, you can basically consume. For me, orchestration, which I think is very important to understand the difference between consume and orchestrate. For me, orchestrate an event or a message is consuming that event and doing something on it. Okay, and maybe sending it to another orchestrator, to another consumer, or to another service bus, or to another data layer somehow. So there is a difference for me, a distinction. Maybe it's the mental model that I use, because when you're talking about serverless computing, you will see consumer orchestrators in many companies, and most of the time they just talking about consumers. Okay.
It's apps, it's logic apps, right? So this idea of
what he just mentioned is a step function is the similarity to is the same service that is a no-code tool where you can basically you have binder triggers, you have connectors that are built by AWS. Okay, in Azure is logic apps. Logic apps is very cool, and you have I think, in my opinion, the best advantage is that you have a million of connectors that you can just basically use, configure in a form, and just have a dispatcher, a consumer, or an orchestrator just building just using clicks, which I believe this is the most important advantages. So you have the connectors and you don't need to use code, even though you have the JSON environment where you can configure the step-by-step functions or logic apps, right? But there are others. You have lambdas, AWS lambdas, and you have Azure functions.
Controlling the system by making sure one thing happens before it's called a state.
Okay, let's move on. Let's move on. Okay. Okay, basically what he's just talking about here is that step function give you the possibility to define, visualize the workflow that you are building, and execute and monitor this workflow. Okay, but you can also have a JSON or what he calls Amazon state language, where you can just configure the step-by-step functions workflows. This is very cool, guys, and I see a lot of people don't use them appropriately. I believe that you should use logic apps if you have connectors that are hard to implement by default, and you don't have default connectors on Azure functions, for example, or on AWS lambdas. And also, I believe that you can basically transport data using logic apps in the fastest way possible, and you don't need to incur in code, which code in this type of services, in my opinion, is a liability. Okay.
I spent about 2 weeks in the Middle East at universities showing them
So
how.
I'm not saying, let me repeat this. I'm not saying that you shouldn't code. I'm not saying you should avoid coding for more specific tasks like transformations, for example.
Build Serverless espresso. If you're not familiar, there's a big automated coffee system that we do. They built it in step functions. Very, very little code. Lots of fun. All right. So step functions integration types. We have custom integrations. We have SDK integrations. With the SDK integrations, I think this number is now low. We've popped this up. We actually use the SDK to talk to all the AWS services. So so we talk AI/ML. Anybody mess with AI/ML? Here's how it works. There's a couple of patterns with step functions. One is called the request.
Okay, basically he's just going to explain how you can create this type of workflows, which is basically a step-by-step no-load code tool that you can configure this step-by-step, which is very easy to do. Okay, the hard things, in my opinion, is to design it properly. Okay, he just mentioned more about it, and he just put together all the orchestration plus choreography, which you have the two different patterns. You can orchestrate and you can send the same data to different places, which is different. Okay, and okay, but let's review this design. Okay, so you have an API gateway that receives all the income requests. Okay, you have a STEM function workflows with somehow also accept data from a different API gateway and send it to the event boss. Event boss has 4 different rules. Okay, so it filtered the data to 4 different, let's say, microservices, let's say pods, right? Or let's say 4 different areas. So you can transform these in different ways. So you have here the first square here is maybe it's just applying this rule to send some. Of course, this is a simplified topic, a simplified image. Not always you have the event that can be directly notified. So you might need to add some transformation or some specific validation of parameters there, parameter configurations there. But this is just I suppose for explaining the general idea. So you have a rule, you have a workflow, which is another step function, and you can send it to another event bus because that event is going to be consumed or orchestrated by a different services. And you have this is another example. You have SQSQ here only, which you have maybe this is just for I don't know, maybe if some specific pattern you put this queue here in the middle, and you have another API gateway and a load balancer. The general idea is you can filter the rules and the events by rules, and you can process them in a different way.
Happy to talk between that loves idempotency. Raise your hand. Idempotency.
Okay, idempotency.
Okay, all right. Well, okay, good. Nerd, right in front here. Nerd alert. Same here. I love it.
I still don't know what idempotency is. Even though this is like the 10th time I see this video. So please.
I'm figuring it out.
No, I'm just joking.
On that. So if you're not familiar with idempotency or what I'm talking about, I'm gonna explain it. When we say idempotency, first time I heard it was like, ooh, I don't want that. Oh, I definitely don't want my system to have idempotency. That's bad. It's a disease. It's actually good, right? Idempotency is a good thing. Okay, so let's talk about what it is. The idea of idempotency is this idea that operations that can be applied multiple times without changing the results.
What is idempotency? Idempotent. The mathematical definition. Operation. Oh, here he uses the right definition. Operation that can be applied multiple times without changing the result. So you have an operation, you have a request that always has the same response, for example.
Okay, being idempotent is the ability to fight against duplication. Now, I'm not going to give you everything we can do because we don't have that kind of time. But I'm going to give you a few steps that we at Amazon take and things that we give you to help you do that on how do we become idempotent, right? So, and again, I'm so sorry, the colors.
Oh, for example, there is yesterday videos. There is a Stripe block, engineering block. So I read yesterday an article. Here you go. Design a robust and predictable API with idempotency. I think now that we're going to talk about this is a very important idea to see how they configure idempotency in their own APIs. So let's go on it, okay? Networks are unreliable. We have all experienced trouble connecting to Wi-Fi and had phone calls dropping on us abruptly. The network connecting to our servers are on average more reliable than consumer level, last mile like cellular or home ICPs, but give you enough information moving across the wire. They are still going to fail in exotic way. Outages, routing problems, and other intermittent failures may be statistically neutral on the whole, but still bound to be happening all the time at some ambient background rate. To overcome this sort of inherently unreliable environment, it's important to design APIs and clients that will be robust in the event of failures and will predictable bring a complex integration to a consistent state despite them. Let's take a look at a few ways. Let's take a look at a few ways to do that. Okay. Planning for failure. Consider a call between any two nodes. Consider a call between client and server. Okay. There are a variety of failures that can occur. The initial connection could fail. Sorry, guys. There are a variety of failures that can occur. Okay, the initial connection could fail as the client tries to connect to the server. The call could fail midway while the server is fulfilling the operation, leaving the work in limbo. The call could succeed, but the connection breaks before the server can tell its client about it. Any of these leave the client that makes the request in an uncertain situation. In some cases, the failure is definitive enough that the client knows with good certainty that it's safe to simply retry it. For example, a total failure to even establish a connection to the server. In many others, true, the success of the operation is ambiguous from the perspective of the client, and it doesn't know whether to try the operation is safe. Basically, what it's trying to say here is you have client and a server. You are realizing different operation between client and server, okay, and you somehow lose the operation, but you need to recover the operation again. And the reason this operation can fail are many. This problem is a classic example of distributed systems, and the definition is broad when talking about a distributed system, in the sense as few as two computers connecting via network that are passing each other messages. Even the Stripe API, and just one of the servers that's making requests to a compromised distributed system. This is important, and the reason I highlighted with the Stripe API is because Stripe is an API product-based company, in my opinion, and it's very important for there to be highly available and reliable system and a reliable API. So every time that I have some API specific interesting on how to improve certain type of characteristics on the API, I go here, and that's why this is one of the most since I'm a backend developer mainly for the last 7 years, I've been visiting this blog a lot. Making liberal use of idempotence. The easiest way to address inconsistency in distributed states caused by failures is to implement server endpoints so that they are idempotent, okay? Which means that they can be called any number of times, or guarantee that the side effects only occur one, or guarantee also that response is the same. When a client sees any kind of error, it can ensure the convergence of its own state with the server by retrying, and can continue to retry until its verifier succeeds. This fully addresses the problem of an ambiguous failure because the client knows that it can safely handle any failure using one simple technique. As an example, consider the API call for a hypothetical DNS provider that enable us to add subdomains via HTTP requests. Okay, we have a cool request here template made to Stripe. Okay. All the information needed to create a record is included in the call, and it's perfectly safe for a client to invoke it at any number of times. If the server receives a call that is realizes it duplicates because the domain already exists, it simplifies ignore the request and responds to a successful status quo. According to HTTP semantics, the put and delete verbs are idempotent, and the put verbs in particular signifies that a target result should be created or replaced entirely with the content of a request payload. In modern RESTful parlance, a modification would be represented by a patch. Guaranteeing exactly one semantic. While the inherent idempotence of HTTP semantic around put and delete are good fit for many API calls, what if we have an operation that needs to be invoked exactly once and no more? An example might be if we were designing an API endpoint to charge a customer money. Accidentally calling it twice would lead to the customer being double charged, which is very bad. Very bad. This is where idempotence key comes into play. When performing a request, the client generates a unique ID to identify just that operation and sends it up to the server along with the normal payload. The server receives the ID and correlates with the state of the request on its end. In the client notices a failure, it retries to request with the same ID, and from there it's up to the server to figure out what to do with it. If we consider our sample network failure case from above, on retrying a connection failure, on the second request the server will see the ID for the first time and process it normally. On a failure midway through an operation, the server picks up the work and carries it through. The exact behavior is heavily dependent on the implementation, but its previous operation was successful, rolled back by way of an ACID database. It will be safe to retry it wholesale. Otherwise, the state is recovered and the call is continued. On a response failure, the operation is securely successful, but the client could not get the result. The server simplified replies with a cache result of the successful operation. Okay, the Stripe API implements idempotence key on mutating endpoints, anything under POS in our case, by allowing clients to pass a unique value in with special idempotence key. So they basically add an ID here and they somehow add the state of the request in this case, and that's how they can understand the state of any transaction and recover that transaction without allowing any duplicates. If the above Stripe request failed due to network connection error, you can safely retry it with the same idempotence key, and the customer is charged only once. Okay, I'm not sure if it's a good idea to continue reading, because this is the general idea of why idempotence key can be important for your API design. Okay, we have okay, let's go back to the video.
It's very dark here. So this is the mathematical definition, right? And from systems, the architectural definition is a message that has the same effect whether it is received once or multiple times. But let's get to the real definition. Was my credit card charged twice?
Actually, he just mentioned the same case of this block, which is very cool. I didn't know that, actually. I didn't remember that he was mentioned about the specific requirement of credit card charge, but it's a very critical, and that's what I went to this specific article.
Anybody gotten that call from mom? I have, more than once, right? It's that, what happened? Were we charged twice? What do we do? All right, so that's the real world definition. So let's talk about where can duplicates occur. Duplicates can occur in a lot of different places, but let's call out a few, right? The first is they can be caused by transmission issues. And here's how that works. So let's say I have a sender, the sender sends a message, but the acknowledgement is not sent back. So the sender, that's a network failure. So the sender's sitting out there going, did it work? Did my credit card go through? Did it happen? So what they do is they send it again, and this time it works just fine, but now we have a duplicate message. We've charged our card twice, or 3 times, or 4 times, depending on how impatient you are, right? So that's one area that happens. A second area that can happen is duplication caused by receiver issues. And I'm going to talk about some AWS services and how we do things. Because at AWS, we build to not fail, but we plan as if we're going to fail, right? Because everything fails. Our CTO says everything fails all the time. It happens, right? So you build as if it's going to fail. So in this would actually be an example of SQS, and I'll explain how this works. So your sender sends a message into SQS. We immediately create 3 or more copies of it. So there's redundancy built in, right? And availability. So we create that. Then what happens is when a receiver grabs that, we put a timeout on that. We say, hey, this isn't available for anybody else. We don't delete it from the queue. It's just hidden in the queue. But what happens if your receiver fails, right? Well, then it's left in the queue, and then receiver 2 gets it also. So that's what when we talk about SQS, we don't say one-time delivery, we say at least once. delivery. And this is how it can be more than one. So the reality is you're going to have a duplication, right? Same process here as if you have a sender, and this can be caused by the service itself. I hate to say it, sometimes services have issues. So we have a sender that sends it, we have it, the receiver one grabs it, and something happens to the timeout actually, and it becomes available again. So now sender two or receiver.
Okay, basically what he's just trying to mention here is that event-driven architecture mainly are holding three components: sender, routers, and receivers. So any of these three components can fill any transaction. Okay.
Receiver two grabbed, we have a duplication.
So how we build idempotent code?
So the first thing we're going to do is we're going to work on deduping in our code itself. Okay. That idempotency tokens. Anybody using idempotency tokens now? Okay. So take a look at this. All right. It's not too hard, but there's a couple of key things.
This is the same strategy that Stripe using the API.
You understand. First of all, an idempotency token is generated at the client. Your client needs to be aware of the token. Meaning, when they send it, a token should be there from the client. They should be regenerated by the client. So if I'm doing a secondary call, it should be the same one. The client should be aware, right? They are unique.
This is very important because this is very important. There is a difference between you generating this token on the client and on any of the other two components that we just highlighted. Okay, the only way to guarantee that a client sent a unique token and this unique token has the information that only needs to be processed once is using the client to generate this type of token. Because if you generate this token on the receiver or on the router, you don't know who's the person or who is the other component that is sending this type of token. You can even have duplicates either way.
Per message, if you're fit, right? Especially in this particular example, it'd be DynamoDB. You can use whatever you want. DynamoDB is a persistence layer that's done by Power Tools. And here's how it works. So you have this client, this invocation. So the invoke say, okay, this token is being worked on and I'm locking it. So if you get it again, it's locked. It needs to respond with this, right? So then we actually process in the Lambda function whatever it was that was going to happen. What's your logic? And the final response is then saved to the record in the persistent. All moved in. So what happens if that fails? So here's the subsequent response. Okay, so that did not receive by the client. So the next request by the client says, I'm going to do it, and I'm going to check, and I'm going to look up the idempotency token, and if it exists, I'm going to return the saved result back to the customer. Meaning they got the same response every time you try it, but we're not creating duplicates in the system. Alrighty? And yeah, I do hold your question because I definitely will answer it. So, all right. So that's kind of how we approach that. So how does that work in our services? So let me show you. So let's say we had Amazon SQS. Okay, this is a service we use. This is a FIFO send message API. So we're going to create a token. So this is what the token looks like. And then I'm going to go ahead and I'm going to send, I'm showing an example of a CLI because, I don't know, it looks cool on screen. So we're sending it and we get this message back, right? And we're going to send it again. And we get this message back, and the message ID is identical, right? It's the same response. We didn't duplicate it. This service is idempotent. Got a big green check, okay? So, same with AWS step functions. So the AWS step functions, we use a start execution API, and we're going to create a token, and then we're going to actually send it, and we use the token as the name. It has different names and things. And so we send that, and we get back the state machine. And we send it again, and you notice we get it back again, and it is idempotent, same thing. So let's look at EventBridge. Okay, we're not going to go through all the services. Like, wow, we have 200 services, buckle up. All right, so EventBridge. So EventBridge, we're going to do the same thing. We're going to create that, we're going to send it. Okay, we've sent our details and everything, and we're going to send it again, and uh-oh, those don't match. Okay? EventBridge is not idempotent. And are you saying, right now you're all saying to yourself, really? You couldn't check that box. You couldn't finish the work on that. If InBridge is not idempotent by design, we don't know what your data is going to look like. You may send the same thing repeatedly, right? So how do you get around that? So here's where you get a little proactive. Okay, InBridge has this idea of an idempotency identifier as well. And so you can have, now here's some things to note about it, because remember our rules, we're not going to use the ID, right? We're going to actually create a specific token and we're going to save it in the metadata. And you can name it anything you want. I don't care. You can name it Bob, right? Except for Bob may easily get overwritten if somebody else wants to be clever and use Bob, right? So we're going to use the client provided idempotency token. And when we send that in, so let's go back to this. We're going to actually add that to our data, right? So we have the idempotency key in the metadata using token. So what that means, if I send this over and over and over, it's going to have that token, but your client knows the identity. So your backend should also be aware of that. So it probably needs to be persistent somewhere. All right, so this is how you look at not building duplicates into your system. So idempotency duration, just real quick, Lambda Power Tools automatically does 1 hour, SQS is 5 minutes, SNS is 5 minutes, step function is 90 days. So this helps you understand how long do we keep that persistent response, right? And these are some of the things, and you can change some of those. Idempotency by any other name would smell as sweet, and I love this because we use different names. Like I said, you can name it what you want. Here's just some examples.
Okay, basically he just mentioned about the same. So you just generate an idempotency token and you control the state of the specific request in this case. Okay, and that's how you avoid duplications, and that's how you always can also validate the state of any specific request in this case, and you can control all the states of the request. Okay. So having said that, I think we just talk about the most important things on serverless, the most important topics. Okay, he's mentioned serverless.com, serverlessland.com, which I think is a great resource for learning serverless computing. Okay, so please review a lot this video. I'm not sure this. I also reviewed this other video about serverless computing by Ron Martin, but I think the Eric Johnson was better. But you can start here and you can see the different patterns. So but you also has a lot of good architecture diagrams that you can review. Serverless pattern architects. The bad thing for me, which I'm more actual developer, is that I don't have the actual diagrams here. I believe it's a good idea to have a server land that holds the diagrams and all the content. It doesn't matter what type of GCP or AWS or Azure, so cloud provider you use. I think it's a good idea actually. So if you are looking for a good idea, that's a good idea. Okay, and you can put all the snippets for any of these specific cloud providers. But in any case, I'm going to talk to you about now Azure Functions, which I believe is very important. This is what I believe. This is one of the most important videos you are not going to find easily in the internet. And the reason for it is because it's a specific niche video and you need to deal a lot with Azure Functions in order to understand the importance of this video. Okay, this video is is related with what no one tells you about what you should or how you should use Azure Functions. And Azure Functions is just the orchestrator or the consumer component, or one of the consumer components you can build. Let me see, I explain this better. Azure Functions is just a way to build serverless computing in Azure. Okay, Azure has AWS Lambdas for orchestration and also consuming natively this type of or implementing this type of architectures. But you can also use Azure Functions. Okay, you can use Logic App, Azure Functions. Logic App is very good, as I explained before, but Azure Functions is also good in different cases. The thing is, to understand Azure Functions, you have to go deep, read as much as you can. here on the Microsoft documentation, which I believe is very good actually. They have a specific scenario when you can use it, the development life cycle, the hosting options. You can the hosting option plans, the advantages. You have flat consumption plan, premium, dedicated consumption plan, container apps. You have the operating system that support premium, dedicated, container consumption. These are the language, scalabilities, constraints. You have everything here, in my opinion. You also have, depending of the consumption plan you use, the server limits, network feature, billing, and it's so on and so forth. So you should read this specific web page if you're looking to learn Azure Functions. Okay, but let's go about this
Real World Serverless, a podcast where I speak with real world practitioners.
So I'm not sure if I should continue this live or should I finish it, because even though we are just talking about, I think we're going to skip this video right now, guys. This is even though I'm going to put this video link in this stream, I'm going to put the stream here, and I'm going to make the next stream on Azure Functions. Let's do it this way. See you in the next video. Thank you for joining us.